So let's put all these things together. If you haven't seen the previous playlists where we've learned how to create visual stimuli, I suggest you have a watch of that. If you're familiar with Python, then you can jump through a lot of the early videos because that's designed for an extremely novice audience. But if you need some help learning how to make a stimuli, have a look towards the end of those videos. What we're going to do now is we're going to just create a very simple made-up experiment with a lot of bugs and a lot of problems, but the general concepts of what we're going to do here should be, quite relevant to how you would design a typical experiment. In the videos after this, what we're going to do is clean up the code and basically make it a little bit more watertight in the logic that we're going to apply. What we want to do now essentially is to create our main program loop and get responses from our subject, and we want to be able to save those responses to our CSV file and our pickle file. So what are we going to do? Make sure that you've got your Psychopy, event and visual and core all on board. What we're going to do is we're going to suppress the output of the output file just for now, because otherwise we're going to basically vomit out a lot of stuff onto our command prompt. So we'll just use a multi-line comment here to suppress the output. And what we're going to do is we've got our output stuff, we've got the current time, current date, good. What we're going to do now is let's create our stimuli, excuse me. For those of you who haven't seen the other videos and want to just have a very quick overview, what we do in Psychopy is we create a window or a canvas. We then create some stimuli. We then draw that stimuli onto the window, and then we flip that window onto the screen from the memory buffer. Okay, that's fairly straightforward in that sense. So what we're going to do is we have to create our window first. So we're going to call it win0 visual.window. How big do we want it? Well, let's just make it a little bit smaller than what we would normally. You would obviously make that full screen if you're doing a proper experiment, but we just want to keep it in this one monitor. So the screen number that we want to do is 0, screen 1. I've got a second screen here. We want the monitor. So if you test monitor, if you've been able to linearize your output, you've got the gamma correction, you've got the lookup tables, then you can go to Psychopy, import all those values that you've used to normalize and standardize your screen, and then that would be the calibration file that you would put in here. We're just using a test monitor, which is a standard one, because we're not going to worry about calibrating our output. The units that we're going to use, we'll just leave it at pixels for now, and the color of the screen that we want, we'll just make it a boring gray. So 0, 0, 0. Remember, it goes from -1 to 1. For this computer, it's an 8-bit value, normalized between mapped to -1 to 1. If you're using something like the Cambridge Research Systems Visage, and I think that's a 10-bit, or the bits plus, I think that's a 10-bit. It encodes it in a 10-bit value. Color, allow full screen is going to be false. You don't have to worry about that. Allow GUI. We don't care about that stuff. I'm just thinking of the other parameters that sometimes we might need for this. So that's our window. Let's create our first stimulus. So we're going to call this stim1, and it's going to be visual.grating stim. And we're going to put that onto the window, which is called win0. The size, let's make it say 150 pixels. It's going to be square, but let's mask it. So now it's in a circle mask, circle. What's the spatial frequency that we want? So it's going to be in pixels. So let's make it 0.05. Cool. The position, we want it to be left of the center, so it's going to be say -100. In the midline, it's going to be 0. Orientation, we'll make the orientation say 90 degrees, and it's going to clean that up. But let's not make it clean it up like that. We'll clean it up the way that we want to clean it up, and we'll set that like that. We need a second stimulus now because we're going to present 2 stimuli. The general thing with a lot of these psychophysics experiments is for your subject to make a decision between 2 choices. It's a 2 alternate force choice test. Sometimes you might want to put a third choice in there, and that's fine. Spatial frequency, what we'll do is we'll bump down the spatial frequency here, and we'll actually bump up the spatial frequency here. We want this one to be to the right, and we'll make the orientation for this one, say 45, not 450, but 45. So we've got our window, we've got our 2 stimuli. What we need to do now is draw our stimuli to the window. So stim1.draw and then stim2.draw. That's still in the memory. We need to then put that onto the window onto the screen. So win0.flip. What we're going to do is we're then going to just wait for 2 seconds, and then we're going to close everything down. We're going to clean everything up. Win0.close. So hopefully if this works, if I haven't made any mistakes, we should see a window come up, 400 by 400. We should have 2 grating stimuli in the middle of that. There we go. One on the left and the one on the right. And you can see we were able to change all the parameters that we wanted to there. We've given them masks, we've given spatial frequencies, we've changed the position, okay? So we can now turn this core.wait off because we don't want to wait, but we still do want the win.close there because we want to close everything down right at the end after we do our experiment. So we've created our stimuli. What we need to do now is, in this way that we're going to create our program, it's quite a dirty and quite a clunky way of making your program, but it should get the job done. And that's what I'm trying to get across here, is we need to now create some containers. Now I'm going to call them containers, but they're arrays or lists. These are going to be empty lists, and every time we run a trial in our main experimental loop, we are going to append into each of these lists the latest experimental parameter or the latest response of your subject or the current time or the current date. And so as we increase or progress through our experiments, these lists will get longer. And you can see that if we run hundreds or thousands of trials, we're going to start to create very long lists. And so that could be one of these problems with making a program such as this. But we're not going to worry about that now. We're going to keep our experiments to say 10 to 15 trials, not hundreds of thousands of trials or thousands of trials. So we need to create some containers. What containers? Well, we need to create a subject ID container. So sub ID. We need to create the date list. We need to create a time list, because remember, every time we run that experiment, we want to get the date and we want to get the time and save that into our CSV file. We want to get the trial number, and we want to get the, let's just say the reward, so ru ori and the foil ori. These are all empty lists, and we want the response. Okay. Now, number of trials. So how many trials do we want? We could set this up using a GUI or an input from the experimenter. How many trials do you want to run today? We're just going to hard code this. Say we want, let's just say 10. We want to run 10 trials. So here we go. For I in range, number of trials. So this will control how many trials we do, because we said, hey, today we want to do 10. And so therefore, this is going to count up from 0 to 9. If you don't know what happens there, go back to my Psychopy playlist, where we talk about zeroth counting. And what do we want to do? Well, let's start populating our lists for our trials. So what was the first trial? It was sub ID, and we can just simply append into our subject ID. We will append the sub ID from above. So I'm going to call that sub ID because subject ID, because it's going to probably cause a clash up here where we've defined the experimenter's name, the initials of our subject. So subject ID is done. The next one that we want is date list. Date list dot append, and in that we want to get date time dot today dot stfr time, and this is the date, so we want year, month, day, like that. Percent year, percent month, percent day, bop, bop, bop. Okay, that goes into that like that. Why have you not enjoyed that? Still got a problem there. So I'm just taking this from up here. And then we want time list will also be append date time dot today strf time, and this will be percent hours, percent minutes, percent seconds, all uppercase for those ones. Okay, now what's going to be the time number? Not the time number, it's going to be the trial number. So the trial number, this is easy. Trial number is going to be dot append, and that's just going to be the loop iterator. Okay, reward ori. We're not going to populate this with anything meaningful. We're just going to hard code this at the moment because in the next couple of videos, we'll basically make the proper experiment. We just want something that's going to save the correct number of values. Okay, foil ori. And then, so we've got this one, and now we want the response. So the response will be, well, we need a keyboard response. Now, if we were running like a OpenCV library, CV2, we could do cvdo.wait key, and wait key, say brackets 1, and then bit shift it, and 0xff that. But we're not, we're using Psychopy, so we would do key equals event dot wait keys, and in here we need to, let's have a look what we need. We need wait keys, the key list, and we need to clear events equals true. So let's go into here. So this is from the Psychopy documentation. We will put this into our wait keys. We don't care for waiting, so max wait equals infinity. Yep, that's fine. So key list, let's give it a list of keys that we want. So let's say if they think it's the same, we're going to say the letter S. If they think it's different, okay, so I'm just going to try and make it symmetrical on the keyboard. Let's just say K. Right, and if they hit the letter Q, that means they wanted to quit, or they want to quit out. Timestamp, we don't want to return the timestamp, but we do want to clear the events before we then pass what the key was to the next line of code. So that looks very ugly. Thanks, Atom Beautify. Something like that. Yep. So now we set up the conditional. So if key, if s in key, we want to response.append 1. Let's just say for now that if they say the same, then we're going to call that correct. Now I know we haven't set up any of those rules yet. Again, we are just trying to create the main loop, program loop, which will then be used to generate or populate the lists, which will then go into our CSV file. What we're going to do in the next videos, again, I'm repeating myself for clear reasons, hopefully, because then you should remember it. In the next couple of videos, we're going to set the parameter randomization. We're going to actually design a more appropriate experiment where these sorts of rules, because we've set them here now, we can populate them more appropriately with the actual changing dynamic nature of our experiment. Oh, what a horrible sentence. Center dynamic nature. You're going to update and make it more correct in the next videos, okay? Okay. Else if, what was L1? K in key, response.append is going to be 0. So if they said different, then that's incorrect. Okay, and else if Q in key, we want to break. We want to get out of this program and go on to the next program. The next bit of code out of that loop. We want to break out of that loop. So let's see what we get. What we want to do is, just because we don't have any output here, what we are going to do is we will go win0.flip. Make sure that we draw the stimulus every time we run the trial. But the other thing that we're going to do is we'll print out the current trial number. And that's, remember, just the iterator. So let's see if we've made any mistakes. Hopefully not. So we should see the window come up. Okay, number of trials is not defined. Okay, because I made a spelling mistake. Because I'm an idiot. Hopefully it works. Window should come up. We should see those two stimuli. And then it should wait until, right, max weight equals infinity. We'll just leave that. I think the default is an infinite wait. You could put a timeout here. You should see the two stimuli, and it should wait until we hit either S, K, or Q. So there we go. Current trial is 0. So S, and we've gone on to the trial 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. We're done. So what we did is we flipped the window, but we didn't draw the stimulus to the window, the stimuli to the window. So we have to remember, always draw stimuli to the window. So I think it's stim1.draw, and then stim2.draw. Because this is how we can change the stimuli, order, presentations and stuff for each trial. All right. So I also want a space here because I don't like that look. See, there wasn't a gap there between the L on the 1 or the L on the 2. So there we go. It's drawing the stimuli. It's waiting for it. I've just clicked on that so it's updated. It's took away what we drew. K. So I've just hit the K button. I hit the S button. I hit the K button. I hit the D button. Nothing's happening. R button. Nothing's happening. T is nothing happening, so it's only looking for the keys that we've got there. If I hit the S, it cycles again. So let's just go back and forth. There we go. We've got the program running through the counter. The counter being the number of trials that we've set, which is 10. Hey, let us now create our output file. Get rid of that end of line expression. So now subject. Our subject ID is going to be subject ID. Our date list is going to be date list. Our time list is going to be time list. Our trial number is going to now be trial number. Rare ORI, foil ORI is going to be the same, and response. Okay, here we go. Fingers crossed we've done it all correctly. Let me just stop and we'll just go back. We've got our main loop here. This is our main experimental loop. It's going to start at 0 and run through the number of trials that we set here with the number of trials parameter. We can set that using an input from the command prompt or through some external file where we've saved all the parameters, okay? This is just one way that we have set the number of trials. What we're going to do is print out the trial number. We're then going to draw the stimuli onto the window and then flip that window onto the screen. We've set this up before in that we have created our window object, we've created our two stimuli object, and we've purposefully made them quite different. We've changed the spatial frequency, we've changed the position, and we've also changed the orientation of those two. If our experiment was to say, okay, how well can a person determine the difference between two spatial frequencies, then what we could do is we could set stim1 to be our reward stimulus, that's the one that's not changed, and stim2 we would call our foil stimulus. And then what we would do is we would, every time we get a response from our subject, we would then say, hey, was that correct or was that incorrect? And then we would update our stimulus parameter, and before we draw it, so it would still be inside our main loop, but then we would redraw it and flip it to the screen, and then the subject would have to make another decision on that stimulus. What we do is we then present that stimuli, and then we basically say, okay, let's populate our data arrays for the current trial. And we're going to add the current trial onto the array containing the previous trials. And then once we hit the number of trials, or the subject has decided they want to give up on life and hit the Q button, we'll break out, and then once we've broken out of this for loop, we then close the window and we create our data frame, save our output data file using the try and the except. If there is a problem, we'll get the except. Okay, so let's run this and see what we get. Hopefully we get two data files, a CSV file, as well as, now I know that's just come up. What I want to do is just go to desktop and just make sure that we will save the data file. Okay, that's not going to do anything until we hit one of those two buttons. So practice data, here we go here. I'll delete that out. I'll bring this across, ready? Okay. So S, K, S, K, K, S, K, S, K, S. All right, so there we go. We've got our two data files here. But you see, we've also got our output here because remember, we've got our print. So output file, print the output file, which is the data array. So remember, we hit S, K, S, K, K, S, K, S, K, S. I think that was the order, I can't remember. Did we save that correctly? There we go. Time 1909 7 seconds. So you can see it took us a while to get that first one, and then we're hitting it every second or so. So we're getting quite a good resolution here every second. And then we've got the responses here. S, K, S, K, K, S, K, S, K, S. So there we go. We have now got that one step closer of including our main experimental loop. We're starting to present our stimuli. We're recording stimuli from the keyboard. Okay, it's quite simple. We've defined what keys we're looking for in the keyboard. So that's another thing that we've done for the first time in this video set. And we're able to save the files now using a file naming system and the file path that what we've set. Yes, we've done it through hard coding all these values. However, it's going to be a trivial thing now that the core program is working to optimize it, to make it better, to make it clearer to you to work, and to make it less likely for bugs to creep in. So we'll leave this video here. What we'll do in the next video is we'll think about an experiment that we actually want to run and where we actually decide to change the stimuli according to how the respondent has responded. Another bad sentence. Anyway, we'll leave it here. Hang in there, and I'll see you in the next one.